Hi everybody, in this video I will be showing you how to simplify polynomial expressions by adding and subtracting. Before we get into examples though, it's important to note what constitutes like terms. So like terms are terms that have the same variables and the same powers, and the key here is that the powers need to be over the same bases. So I gave a quick example here, some quick examples of what makes like terms and what are not like terms. So 2x and 3m, not like terms, and the reason is because one has an x, one has an m. 2x and 2x to the fifth power, again, not like terms because this x here has a power of 1, but this x here has a power of 5. So the different powers mean that they're not like terms. Even though they both have an x, those powers make the difference. In the third case, we have x squared y. And although the other one looks similar, but if you look carefully, the power of 2 is over the y. So this is x to the power of 2 times y. This is x times y to the power of 2. So the powers of 2 being in two different places means that they're not like terms. Okay. In the last case, we have like terms. So yay, we finally got it. This is x to the power of 2 times y. This is also x to the power of 2 times y. And because the variable components are identical, they're like terms. The coefficients don't need to be the same. That's why I haven't been mentioning them. Okay, so with those things in mind, let's go ahead and jump into our first example. Now, there are different strategies to adding and subtracting. My focus today will be on one strategy I like to call the sideways method. The sideways method draws pathways from one like term or one term to its like term in another group. So as you can see here, we have a polynomial that is attempting to add with a trinomial. So I'll begin with the leading term, and I want to see if in the other group I have a term with the same base and the same power. In other words, I have a like term. So I can see that this 3x to the fourth will combine with 2x to the fourth. I also see that this negative 2x to the third will combine with this 9x to the third. When I look at the x, however, and I go over here to the trinomial, I don't see a term that it will combine with. There is no like term for this plus x because there is no other term in this trinomial with just x by itself with a power of 1. Okay, so I circle it so I don't forget it because I do need to include it in the answer. This 5 will combine with the negative 10. Neither of those numbers have a variable, so they're constant terms, and that means that they're automatically like terms. So what you can do at this point is pair them up. You could say, all right, well, I know that 3x to the fourth will add with 2x to the fourth. I know that negative 2x to the third will add with 9x to the third. Now, this plus x that I circled will come down by itself. It has no other term to combine with. So what you started with is what you end with. This plus 5 will combine with the minus 10 or the negative 10. And now you just go ahead and put stuff together. Bring this down. Put these two together and we are done in a moment. So this will make 5x to the fourth power. This will make plus 7x to the third power. This plus x, just drop it down. And then 5 minus 10 is negative 5. So with that, we are done. Okay, in the second example, we have something similar, but if you notice, this time I am subtracting the left group with the right group. So when you subtract, you have to keep in mind what a negative does. There is secretly a 1 right here. So if it helps you to visualize it better, actually write the 1 in there. And what you have to first do, unlike in the first example, is you have to first distribute that negative 1 into that binomial. So what we get is, from here we get a plus 2y and a minus y to the fourth power. Now all this over here, all this will just drop straight down because we haven't done anything with it yet. while we were waiting to distribute the -1. So this is now 18y to the 6th, still -3y to the 4th, still -7. And now I can go ahead and try to pair things up. So again, I want to look for like terms and then draw pathways to them. This 18y to the 6th power doesn't have any other term that I will combine with. So what that means is I will circle it, because I know I need to include it in the answer, but there's no pathway for it. This -3y to the 4th, the -3y to the 4th will join with this -y to the 4th. Okay, the -7, let's see, there is no other constant term, so again, I will circle that. And this 2y, well, again, there's no other term it will combine with, so I will circle that. So really, the only thing that will combine with something else are these two terms with the y to the 4th powers, here and there. Now, when you're sorting this out, remember, you want to put this in standard form, which is highest power down to lowest power. So I will put 18y to the 6th power as my leading term, because it has the highest power, followed by -3y to the 4th power, which will combine with -y to the 4th power, okay, second highest powers, followed by my +2y, because that's my third highest power, since I still have a y, followed by my -7, which has no y at all. Therefore, the degree on that term is a 0. Okay, so the only thing I need to combine are these two terms here. Everything else will drop straight down into my answer. And what I get is this. I get 18y to the 6th. This becomes -4y to the 4th, plus 2y, drop straight down, -7, drop straight down, and that is the end. So I hope this video helped you out. The key, again, is to recognize what the like terms are. So you want to go by same variable, same power, and the power has to be over the same base. Okay? So please stop by, leave a comment if you have any, and like always, thanks for watching. Bye-bye.